Hello students, I hope you are gelling well with the topics covered in the previous episodes. We are on the way of describing motion, and in this process we have covered about the concept of point object, frame of reference, scalars, vectors and distance and displacement thus far in the previous episodes. Today we will study how to measure the rate of motion or to describe the measurement of rate of motion. In this episode, rate of motion can be measured in two ways. Only if you are interested in magnitude only. You are measuring the rate of motion, means amount of motion taken place with respect to time. Rate of motion is amount of motion taken place with respect to time. If only you are interested in the magnitude, then you call this term speed. Yes, but if you are interested in the magnitude as well as direction, means how much motion has taken place in the given time interval, at the same time you are interested in knowing in which direction. So magnitude and direction both, if we are interested in calculating, we call this term velocity. आज हम rate of motion के बारे में पढ़ेंगे. Speed जहाँ सिर्फ magnitude of motion है, magnitude के साथ direction भी account में लेते हैं, तो you call it velocity. पिछले episode के according we have already covered that if you take only magnitude into account, you call the quantity scalar quantity. And if you are considering both magnitude as well as direction both, then velocity is going to be a vector quantity. Let these things be registered in your mind. Now, how to write the expression mathematically? Speed or velocity? Generally, we prefer to denote both the terms with V only. So, V is equal to distance travelled upon time taken. We are measuring the rate of motion as how much distance has been covered in the given time interval. Whereas velocity is the displacement upon time taken. How much has the body displaced? And you remember, displacement is the difference between the final position and initial position. So displacement upon time taken will give you the measure of velocity, velocity being a vector quantity. This is a brief introduction of the topic. The SI units. How to get the SI units? From the formula itself we get the SI units. It is velocity is distance upon time. Distance is measured in meters, SI units, and time in seconds. If you take CGS units, then meters, distance covered is in centimeters and time taken in seconds. Similarly, SI unit of velocity is meters per second because displacement is also measured in meters, time in seconds, and CGS is centimeters per second. Now we will study in detail about various types of speeds. So we will see the various types or the categories in which we can keep speed. The first one is uniform speed. Now, in order to understand uniform speed, let us consider a situation. See, I have not written the definition, I have left it blank because you are going to define it once you understand what is uniform speed. Because once we understand the concepts, we can always frame them in the form of words and definitions. Bugging up the definitions will not help us too far. So, uniform speed. Consider a situation that you are in a vehicle and the road is completely, or you can say there is no traffic, and you have got a very good smooth ride over there. And there you are having a particular distance. Let us make a distance time table over here. Let us say initially in the first hour you started from home, say at 9 o'clock in the morning. And in the first hour, that is from 9 to 10, you were able to cover 50 kilometers. We are marking distance covered and time taken. And as I told you, it is a rare scene in India, but still let us imagine a very nice road and there are very few vehicles on the road and you are able to drive at a good speed. And you are able to drive at a constant speed without any cats and dogs frequently crossing your way. Okay, so you can imagine it to be a highway even. So the time taken, initially you started at 9 o'clock and 9 to 10, 1 hour, you're keeping track of the time and distance, and you said my distance covered by my car or vehicle is 50 kilometers. Then again after 1 hour, say 10 to 11. Again after 1 hour, in the time taken 1 hour, the distance covered is exactly 1 kilometer. Seems to be hypothetical. Never mind. We are just trying to understand uniform speed. Again from 10 to 11, you started 9 to 10, 1 hour, 50 kilometers. 10 to 11, 1 hour, 50 kilometers. Again 11 to 12, again 1 hour. The distance covered is 50 kilometers. We call this type of speed as uniform speed. Now can you put it in words or define it? Yes. A body covers what type of distances it is covering? Equal distances. You can very quickly make out that the distance covered is 50, 50, 50. It can be 40, it can be 60. Just an example. So if a body covers equal, from here, let me change my pen so that we can give remarks to the key terms. A body covers equal distances in, what can you comment upon the time intervals? Are they also equal? Yes. Every 1 hour you are taking note of the distance traveled. So a body covers equal distances in equal time intervals. Then the type of speed is called uniform speed and the motion is called uniform motion. You describe such a type of motion as uniform motion and the speed is said to be uniform speed. When a body covers equal distances in equal intervals, equal time intervals, the speed is said to be uniform. Then let us consider the second situation, non-uniform speed, the actual scene of our roads, which we come across in our day-to-day life. So you started at 9 o'clock. In the first 1 hour, luckily you got clear road and you were able to cover 50 kilometers. Then after 1 hour, that is 10 to 11, you are keeping track of distance. But you can see all of a sudden the office time has started and so many vehicles are gathering. The vehicles are increasing on the road. So naturally when the traffic increases, what happens to your speed? In the next it is 1 hour. I'm sorry, this is 1 hour. Next 1 hour, you have traveled or you managed to travel only 45 kilometers. You could not keep up your level of 50 kilometers per hour. So the traffic increased and your distance covered has gone down by 5 kilometers. Now it is 45 kilometers. Then again next 1 hour, that is from 9 to 10, 10 to 11 and 11 to 12. Next 1 hour you are keeping track and you can see that the traffic has increased even more. So you could only manage to cover 40 kilometers in the next hour. And now you are surprised. What happened? Why am I not able to cover that distance? It's because of the traffic. But now what do you call that type of speed? Yes, obviously the speed is going to be non-uniform speed. How do you define it? A body covers what type of distances it is covering? Yes, you can make it out 50, 45, 40. Unequal distances, covers unequal distances in equal, you can see the time intervals or slots have been taken equal. A body covers unequal distances in equal time interval. such a type of motion is called non-uniform motion, and you call the speed to be non-uniform speed. In the coming up episodes, we will plot the graphs also, but for that you have to wait a little while. So we have covered uniform speed, non-uniform speed. We are yet to discuss, or we are yet to cover average speed. I hope you have understood. Unequal distances in equal intervals of time give you non-uniform speed, and the type of motion becomes non-uniform. Let us see the concept of average speed. So, just recall what is non-uniform speed. It is distance covered upon time taken where the distance is unequal whereas the time intervals are equal. In most of the places you will find a definition of this type. Sometimes you may have a confusion. What if the time interval is also unequal? Yes, that can also be there in the definition. There is no such, what you can say, fundamental rule to write always equal time intervals. You can have equal distances in unequal time intervals. That is also correct way of defining. When a body covers equal distances in unequal time intervals, that is also non-uniform speed. So non-uniform speed. Whenever a body is moving with non-uniform speed, there we have to calculate the average speed. What is average speed? It is total distance travelled by the body over a given time interval. Total distance travelled upon a given time interval. We represent it as delta x by delta t, whereas it is big change in x upon big change in time. What is big change? It is the, what you can say, from the origin, how far the object has gone, and initial time and the final time gap, time interval. So in this situation, if I have to calculate average speed, what will I do? I will find the total distance travel. Let us do it for the same situation. Total distance travel, it is 50 plus 45. What is it? 95. So 95 plus 40. What is it? 50 plus 45. This is 95. 95 plus 40, 135. 135 plus 55 comes out to be 190 kilometers. So the total distance traveled is 190 kilometers. And what is the total time taken to cover that distance? 4 hours. 1 plus 1 plus 1 plus 1. Total duration is 4 hours. So what is the answer we are getting? We are getting approximately, you will get 47 point some value kilometers per hour. So what we are getting, this is 4, 16, 37, 28, 2.5 we can say. It is 47.5 kilometers per hour. What is this? This is the average speed with which the vehicle moved. Sometimes its speed was 50 kilometers per hour. Sometimes its speed was 45 kilometers in 1 hour. Sometimes its speed was only 40 kilometers in 1 hour. And sometimes it picked up a speed of 55 kilometers in 1 hour. So it had this speed swing. What happened? Sometimes it could move with a maximum speed of 55 kilometers in one single hour. Sometimes the speed dipped to only 40 kilometers in 1 hour. So this swing calculation, taking the average, on an average what was the speed? It is 47.5 kilometers per hour, total distance travelled upon total time taken. I hope you got this concept. We will be moving further with the detailed understanding of the concept of velocity, but for that I would advise you to take a break, go through the things, practice little stuff about these topics, and we will meet again in the next episode. Thank you.